Discuss parabolas. The conic section of a parabola is when you have a cone and you're slicing it with a plane and it creates a singular U shape. Things that you've probably worked with parabolas in the past. Things that you may not have learned about parabolas is that we just have one focus point and it's in the curvature of the parabola. Now on the other side of the parabola, there is an invisible line, the directrix line right here, okay? The reason that there's a directrix line is because the formal definition of a parabola is the set of points such that the distance the points are to the focus and the distance the points are to the directrix are equivalent. So I just put this green point right here on the parabola. We can see that this distance and this distance are the same. And as we move out farther, yes, this distance got larger and so did this one, and they consistently be the same. The measurements that we are going to discuss are the distance from the vertex to the focus. Now, based on what we just said, that distance is the same as the distance from the vertex to the directrix line, okay? And that distance is p units. Now, why do I care about that? Well, if you look right here, we can see that they have isolated the x squared or the y squared. And then on the other side of the equal sign, there's a 4, there's a p, and there's either an x or a y, depending on which equation, okay? Now, if the vertex of the parabola gets moved and it's not at the origin, then just like we had with the other conic sections, you will adjust the x or the y accordingly. And here's what I mean since we're talking about this. When the center, or vertex in this case, is moved not on the origin, we'll have this format where the vertex is HK. And if you look at one of these, you will see vertex is HK. Okay. Now, distance from the vertex to the directrix line is p units. The vertex to the focus point is also p units, and that p units we can find from this form for the equation. There is an entire proof for why there is a 4 in this equation. That will be a separate video. Let's go back up and do some manipulations. Okay, if we have a parabola that opens right and left, you'll have a y squared piece. Okay, if I have a parabola that opens up or down, then I will have an x squared piece. So let's look at this next example, and we'll kind of lay out these pieces as we go here. Here, I have y squared equals 24x. I know already, just by looking at this, that it's a y squared. So that means this parabola is either going to open to the right or the left. Not both, just one. Okay, and here's how we're going to figure it out. Now, my h and my k, I don't have them in there with the x and the y. They're 0. So I can see automatically that my vertex, which I don't have listed here, my vertex is going to be 0, 0, because it's hk in the form, which we'll see in a little bit. I'm now going to focus on what is the distance from the vertex to the focal point, or in other words, the distance to the directrix if we go the other way. Well, I know that 24 is going to equal 4p, so p is 6. Since p is a positive 6, this means that this parabola is going to open to the right. Okay, so far, I like to plot as I go. So let's have that be the y-axis. There's my x-axis. There's my focus point. I know it opens right 6 units over in both directions. I'm going to have pieces of information. So I know this just means it's going to be this way, right? So I know that 6 units this way, 1, 2, 3, 4, 5, 6. And since it's going to curve to the right, this will be my focus point. I'm going to go back to my vertex and go the other direction. 1, 2, 3, 4, 5, 6. This, being at -6 now, is the directrix line. And it is a vertical line, x equals -6. All right, so the focus was at +6, 0. The directrix is the vertical line, x equals -6. Now let's talk about what's the end point of this lattice rectum. Well, I'm going to go back up to our pictures, okay? If we look here at this one, what we see in red is the lattice rectum. It is a segment that goes through the focal point, okay? It's parallel to the directrix line, okay? It goes through it, and the endpoints of it land on the parabola. So are points on the parabola, okay? If you look here to this one, this is your lattice rectum. If you look here to this one, it's right there, and right here, and up here, they had it in blue, okay? So here's what I know. I know that I will have a segment here. I'm going to make it sloppy at first and erase it. So my parabola is going to open to the right. This, where the x value is 6, we have our lattice rectum. So what is the y values? Okay, so for the lattice rectum, what y values do we have when x is 6? Okay, so I'm going to take my equation. 24 times 6 is 144. I'm going to square root. When we square root, we put a plus or a minus in front of it. The square root of 144 is 12. So that means when x is 6, y is a positive 12, or when x is 6, y is negative 12, which does make sense if we go back to our graph. Okay. This was the focus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oof. Okay. 1, 2, 3, 4, 5, 6. I got lucky. All right, so this is where 12 is. This is where negative 12 is. And this, then, is how wide our parabola is going to be, and it's going to keep going because that's how parabolas operate. And the lattice rectum is this segment right there. Goes through the focus, ends on the parabola. Okay? All right. Let's move on. Graph x squared equals negative 6y. Identify and label the focus, the directrix, and the endpoints of the lattice rectum. And obviously, we're going to identify the vertex also. And in this case, it's 0, 0. Okay? The form x minus h squared equals 4p plus or minus, right? Times, in this case, y minus k. hk is the vertex. So for us, that's 0, 0. Okay? I'm going to go after p now. 4p has to equal negative 6. So p is a negative 3/2. Okay? So from my vertex, let's establish whether or not we're going up, down, right, or left. Well, since it's an x squared, it's up or down. Since p is negative, it's going to be down. Okay? If p is positive, it's up. P is negative, it's down. All right. So vertex, I'm going to go down 1.5 for the focus point. I'm going to go back to my vertex, go the other direction 1.5. This is my directrix line. The directrix is y equals positive 3/2. Okay, the focus is 0, negative 3/2. And the endpoints of the lattice rectum. So we know that this is going to curve down, right? Where are the endpoints of the lattice rectum? And that can actually help us graph. And it can give us an idea whether or not this is narrow or wide. Really, any points can, but often there's some significance with the line that goes through the focus. So for this one, we know that the y value, what x values do we have when y is a negative 3/2? So we're going to go to our equation. X squared equals negative 6 times a negative 3/2. We're going to get x squared equals 9. Our lattice rectum endpoints are square root. We'll get 3 for x, and we'll get negative 3 for x. And the y value is negative 3/2 for each one. So that means 1, 2, 3, negative 1, 2, 3. There's our parabola, and this is our lattice rectum with those two endpoints. Okay. All right, now let's work this backwards or a little differently. Here it's saying, what is the equation for the parabola when the focus is negative 1/2 and the directrix is a positive 1/2? All right. Focus is negative 1/2, 0. Directrix is x equals 1/2, which is a vertical line. This means that it is going to open left. It also means halfway in between them is going to be where the vertex is. Well, it's a half a unit to the right and half a unit to the left. So from the center, so this center right here is our vertex. So, okay. And we know the focus. And what is P? P is the distance, right? From the vertex to the focus, from the vertex to the directrix. Now, it opens left, so P will be a negative. Okay. Now, if it opens left, that means the form is going to have a y squared, because y squared is your opens to the right or opens to the left. Now, I didn't put h and k in there because the vertex is your h and k, and it's 0, 0. Okay, so y squared equals, if I put my p value in there, I will get a negative 2x. And there's the equation for the information they gave us. And it didn't say anything about finding the lattice rectum. We could certainly plug another point in to get some kind of an idea and use symmetry to draw a good sketch. So, like, let's say, I don't know, let's plug in an x value of negative 2, right? This was negative 1, this was negative 2. If I plug in a negative 2, y squared equals 4. Oh. Those 2 points will be on my parabola. They are not the endpoints of the lattice rectum, though, because that segment does not go through the focus. All right, now let's start moving the vertex around. So it is not on 0, 0. And we already saw that the only difference that is going to have is it's going to shift, right, the stuff that's inside the parentheses with x and then with y also, okay? Obviously, it's going to change where our focus is. It's going to change where our directrix is and all of that, but because the vertex is moved. Okay, so let's look here. Here, let's identify the vertex. Vertex we know is HK. So looking at this, H is in with X. And remember, format had a minus sign there, so really I have a double negative. So my vertex is a negative 3, positive 1. So always in with X is the H. Okay. Let's see, since it's a y squared, this is going to be an open right or open left. So it's either a right or a left. I don't know which yet. Actually, I kind of do, because 4p equals negative 16, which means p is a negative 4. Which means it's going to open left. Okay? Get some data points on here. Here's my y-axis, x-axis, vertex negative 3, 1, 2, 3, up 1. There's my vertex. I know it's going to open left. So I'm going to go P units left and right. And yes, P is a -4, but that's the negative really is indicating which direction you're going to go, right? So some people say, well, I already just there, the fact that there's a negative there tells me it's going to be left. Okay. So 4 units, 1, 2, 3, 4 more. There is going to be your focus. And then 4 units in the other direction, 1, 2, 3, 4, is your directrix line. So this is at a -1. So directrix is x equals -1. Focus is, well, if this was -3, this is -7. So focus, -7 up 1. Okay. Axis of symmetry, well, I'll come back to that. So I have my focus, I have my directrix, endpoints of the lattice rectum. So I know that this parabola is going to open left and right, right? How wide? Well, let's find some data points and let's use what is y when x is -7, because that'll give us the endpoints of the segment that goes through -7. So y minus 1 squared equals -16 times -7 plus 3. And we're going to solve it. Positive 64, square root each side. We will get a positive or a -8. And then we add 1. So we'll have a positive 1 when we move it to the other side, and then add or subtract 8 from that, which means we will get a 9 or a -7. So what does this mean? Endpoints for the lattice rectum are x is -7, y is 9. X is -7, y is -7. Because we knew x and we wanted to find their corresponding y values. So where is that at on my grid? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's where 9 is. Okay. And if you want, you can think about that 8 being 1, 2, 3, 4, 5, 6, 7, 8. And then the other way. Should be here at -1, 2, 3, 4, 5, 6, 7. So this is the lattice rectum, and this is the width of my parabola, like so. So got the endpoints right here. Got my focus. So I got my axis of symmetry. So axis of symmetry, if we folded this in half right here, my axis of symmetry would be horizontal line y equals 1. Check. Focus I have, directrix I have, endpoints I have. Okay. All right. Let's just practice a couple more. Graph. So if you recall from our video on ellipses and hyperbolas, sometimes we're given the equation in general form, not standard form. The standard form is the nice one where we can pluck out the vertex, pluck out the work on the foci, right, and go from there. So let's manipulate this general form into standard form, okay? Now, remember here, right, remember this one's going to have an x squared, and so the form that we're ultimately shooting for is going to be, I'll go down here with it, x minus h squared equals 4p y minus k in a grouping. Okay, so that's what I'm shooting for. So I'm going to put the items that have x with them on the left side of the equal sign. On the right side, I'm going to move everything else. So positive 28y plus 208. Okay, and now I'm going to complete the square. Remember, our goal is to have x minus and a number squared. I'm going to cut that middle term in half. So I'm going to cut the 8 in half and make that a 4. So what does that mean? That's really, if you multiplied this all out, that means that up here we're missing a plus 16. So I'll add plus 16 to each side. That's the only way to keep my equation balanced. Okay, which means on the right side I have 28y plus 224. Okay, Now, the left side looks fabulous, right? The right side, I need to look a little different. I'm going to, if you notice in this parenthesis where y is, there's a 1 in front of it. So I'm going to factor out a 28, okay? If I factor out a 28, I will have a y plus, taking out 28 will give me an 8 here, okay? This means that so now that we have that form, I have my h and I have my k. So hk, which is the vertex, is 4, -8, okay? Now, I can see that the 28 is what 4p is equal to. So, if 28 equals 4p, then p is 7. Okay, and the fact that this was positive means that this parabola is going to open up. Okay, this is the vertex. All right, let's put some stuff on the grid as we go here. It's going to open up. So I'll put my y here, my x here, 1, 2, whoops. There, at 4, -8 is my vertex. If I go up 7, that'll be my foci. If I go down 7, we'll be at -15, and that will be my directrix line. Okay, so directrix is y equals -15. Focus is 4, -1. And lastly, I do believe they want the endpoints of the latus rectum. So I know that this parabola is going to end up, right? It's opening up. So, and we're going to go through the focus. So what x values have a y value of -1 is the question. So we go to our equation right here. I'll write it and just finish this side of it. Here's the equation we're working with, okay? So x minus 4 squared equals 28 times, if I put a -1 in there, I'm going to get a 7. Okay? 28 times 7 is, oh goodness, 169, I believe. Running out of room. I got to go over here. All right, so now I have x minus 4 squared was 196. No. 28 times 7. Oh, it is. Okay. X minus 4 is equal to a positive or a negative. If you square root that, you're going to get a 14. My x values are going to be a positive 4 plus or minus 14. So in other words, I get an 18 or I get a negative 10. What does that mean? That means the latus rectum's endpoints have an 18 for x when y is -1 and a negative 10 for x when y is a -1. So those are the endpoints of our latus rectum. So these are all the pieces that they asked for, kind of down here. Okay. All right. 18, -1. If this is 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh. 13, 14, 15, 16, 17, 18. Not a fan, but I didn't have a big enough grid, or I didn't plan enough ahead. The other point was negative 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. So this is a very wide parabola. Like so. Okay. All right, I got one more. A cross-section design for a travel-sized solar fire starter is shown in the figure. The sun's rays come in reflect off the parabolic mirror towards an object at the igniter site, which happens to be the focus. Because the igniter is located at the focus of the parabola, the reflected rays all bounce off and go to that spot, creating a fire in that location, okay? A, find the equation of the parabola that models this fire starter. Assume that the vertex of the parabola is the origin at a coordinate plane, or on a coordinate plane. So this is the vertex. So that means this is your grid. HK then is 0, 0. Well, this is the focus point, so I can already see that the p-value then from the vertex to the focus point is 1.7. Looks like all of this is in inches. Okay. What am I missing? And it opens up. So if it opens up, then I'm going to have an x squared. So x minus 0 squared is equal to 4 positive 1.7, 4p, y minus 0. So my equation is x squared equals 6.8y. That's the equation for that parabola. Okay. Now part B, use the equation to find the depth of the fire starter. Okay, so take a look at this. It's misleading. You might think that the depth of the fire starter is the p-value, but it's not. There's a gap. It looks like it's falling a little bit short. So basically what I'm trying to get at here is don't assume the depth is 1.7, because here they're basically saying it's not. We don't need that much of the parabola, the mirrored parabola, to have a fire start in the focus spot. So since that's the case, what is the depth, right? So I'm going to use, so since this is the origin, I'm going to use this distance out to figure out the y value, okay? I want to know this y, which is the depth, 4. If this is 4.5 from side to side, then this is 2.25, okay? So what is y when x is 2.25? Excuse me. Use your equation. 2.25 squared equals 6.8y. We solve it. 0.7445 inches deep. That is the depth at that spot. All right, that's it for parabolas.